Hello everybody, thank you for giving me your time and watching this presentation. I am the Technical Director at Keynetix and primarily specialise on the BIM and 3D visualization aspects of geotechnical data management. But before we get into this webinar in any big way, let me show you this. Okay, a little video, but I'm going to do it for real later on. So this is a real-time video. So hopefully you can see this if we hide the poll. So what we're looking at now is we're inside AutoCAD Civil 3D and we're connecting through to some software called HoleBASE Si, which is a central data management system. So we have all our data managed, and if you're managing your data correctly, it allows you to do things like this. So I'm now, as I click here, generating civil 3D surfaces, joining my borehole data together. So you can see we've just created a whole big range of surfaces. Now I'm going in to generate my section. So I'm going to use AutoCAD type functionality. I'm going to tell it not to hatch things. I'm going to now draw where I want my alignment or my long section line to be. I could do a more complicated one. I could pick an existing road alignment if I wanted to, but I'll just use this one here. And all I'm doing now is telling it where I want my section to be. And there we have, I haven't actually timed it in this case, but probably around about a minute or so, we have generated a section, geotechnical section. And because we've used AutoCAD Civil 3D, I can change my alignment. I've created another one. Really fast, really easy to do. So just to show it once more time, let's just do another one. Let's just do one going across my site in this particular case. So there we are. We've drawn a quick line across the site. I'll hatch this lot all in, but this time I perhaps do it on, say, legend code. So I could be doing it on soil classification if I wanted to. Doesn't really matter. And there we go. And now we have our second cross section drawn. A whole thing done in less than 2 minutes. So what I'm just showing you here is that if you manage your data correctly, lots of things are possible. I mean, if you can generate cross sections and visualize information so much faster, it gives you much more time to actually look at and study your data, study your geotechnics, and hopefully do a more refined, a better decision, spot problems more earlier than what you would normally do, because you're not spending your time doing the drafting, you're spending your time looking at and understanding your data. In a similar scenario, we've got this right here. If we can pull the data quickly into AutoCAD Civil, then we can start using it to visualize and wondering what's going on around the site. So here I've got a ground survey and I've draped some a aerial image over the top of it. But look now across my site, I can very quickly see where have I got different geologies. And I've actually, as we pull the data in, we've put it onto different layers. So for instance here, I can come along and turn off all of my different types of geology I have across the site. And now just start turning on where we found different styles of geology as we did the drilling of the holes. So we have some peat in one area, we have the red clay in another area. And can you see how quick and easy it is to see this geology in context of the actual site? Compare that with the traditional way of working where you may have a site plan and 50 log sheets and then start working and producing information from there. It's much quicker, much easier way to understand what's going on. So this all stems around managing and looking after your data correctly, and then it allows you to do things like this. So what we're going to do in this webinar is really cover some of the steps to managing your data, controlling it inside some software called HoleBASE Si, then look at in more detail how we can then go and start visualizing it, bringing in those 3D boreholes into AutoCAD Civil, creating surfaces, going ahead and doing those dynamic sections, and we'll look at those in more detail, and looking at how we can visualize other downhole data, perhaps like water strikes locations, perhaps levels of contaminants across the site, and we'll look at that in detail as well. So I won't go into a big talk on what geotechnical BIM is, or applying BIM principles, but for us it's really around managing digital data. If you've got good control of your digital data, then you can agree processes for changing and exchanging that, how you share it with the wider team, and working with that data for the whole life of the project and beyond. So you use that information time and time again. So I'm not going to go into great detail in here, I'm just going to jump into the software and start showing you. But for us to do a lot of geotechnical BIM, we use our product called HoleBASE Si. So you've got the central core of data, and if you've got that data in this central core, then you can use it. Perhaps you can use existing projects. You can look at when you've got a new job appearing in a new area. You can look at existing data. You can look at GIS maps. You can pull the whole information together to help you refine your site investigation. Where are you going to put your boreholes? Where best to drill them? You're not starting from scratch. You're building on existing knowledge when you come to do that, if you've got the data in your central database. You then go and do your site investigation, you collect data, you may be using software like plog or something to enter the data on site. That can come back into HoleBASE, and then you can use HoleBASE to generate your borehole logs really quick, really easy. Now you may well say, oh, actually we can do some of this stuff already. If you're using, say, Bentley Gint, well, this is a replacement for Bentley Gint. However, when you see the speed and ease in which we can integrate it and use the data, you think, perhaps this gives us extra opportunities. We can do things quicker, faster, easier, and perhaps do better designs by using it. So as we get the data into HoleBASE, another thing we can do is start scheduling all the lab tests that we want to do on it. We don't need to write it down on bits of paper. It's all done centrally in the data management system, and then we can send that off to the labs to perform our tests. We import all the data from our labs, get it all into HoleBASE again. So at a click of a button, we can generate reports, charts on that information. We can start analysing it, trying to work out what the site characteristics are, what's going on in the north end, the south end of the site, and start doing the 3D visualised interpretation of it. But what happens in the new world nowadays is that this used to be a nice linear process. You start at the beginning and finish at the end. But what we're finding now is the information that you're finding in one part of the site, the 3D interpretation analysis, is actually going back in to work on phase 2, so you can plan where best to put your new borehole. So you're reusing that information, you're building that information all the while. And that's what we consider as geotechnical BIM, and that's what we do as a company, is concentrate on this use of the data and measurement of the data. We do it through our product called HoleBASE Si. HoleBASE Si Professional is what I'll be showing you today, and I'll also be showing it in conjunction with our extension for HoleBASE Si, which for AutoCAD Civil 3D, that allows us to bring all that geotechnical data in and start using it and visualizing it inside AutoCAD Civil 3D. So very quickly, these are a whole series of different outputs we've got. So perhaps you're using HoleBASE to plan where you want to put different boreholes. You're bringing in aerial photography, background mapping, you can plot out, give that to your drilling team. They can go out and actually drill the holes in the right place. Okay, so it's all self-contained, it's quick and easy to do. As we collate the data, bringing it in within HoleBASE itself, this is not even touching AutoCAD Civil. You can generate quick sections, but go ahead and generate a whole series of borehole log templates. Very fast, very interactive to do. Design your own log templates as well. So again, moving on to it. The data you've got coming back from your labs or your in situ tests that you've done, you can pull that data through into Excel and generate charts and outputs from inside Excel at a click of a button. And of course, we can take it into AutoCAD and start modeling it inside AutoCAD Civil, or using it and visualizing other downhole data. So on the left, we're looking at levels of pollutants across the site. On the right, we have water strike information, we have installations, we even have core recovery percentages being shown. So there's a whole series of information that we can show. If we're managing that data correctly, we can bring it and show it inside AutoCAD Civil using HoleBASE Si. So what I'm going to do is a quick 5-minute demo of HoleBASE Si, and then we'll get on to using them and working with the civil stuff in more detail. I should say, If anybody has any questions at all, please don't hesitate to use the question box, put questions on there, and we'll do the best to answer those. Stephen is looking at those, and if there's any questions that he can't answer, he will ask me, and I'll do my best to answer them through the webinar. So please feel free to ask any questions you like. So before I go on further then, let me go in and actually show you HoleBASE. So I'm just firing up HoleBASE. So HoleBASE is software where we can link through to a database. We use Microsoft SQL Server at the heart of it. It comes out of the box pre-configured with the ASTM standards. So despite my accent, we do make it work with USA standards straight out the box. And as we log in, it's connecting through to my database, and based on my security rights, giving me access to all the projects I have available. So in here we come through, this is what we call my project list. I can go and open up a project, or in this case I'm just going to say to it, can you please zoom to the project on a map? So we can see where my project is now on the map on the left hand side, and as I zoom out, this particular project is down in near Atlanta. This is Lake Lanier down here, but I can see I actually have a second site up here. If I'm actually going to start working on a new project, or I've been even asked to tender to bid for a new job, I can perhaps go into this project and look at all the information related to it. It may give me a lot of information that is going to be really useful for my new project. And in this mapping, by the way, I have not done it here, but I can bring in aerial photography, so I just come through here. We use Microsoft Bing mapping. We use that because you can print it out, put it into your reports. We use full licensing for it all, so you can actually use it in reports that you supply to your customers, etc. But let me now go in and open up this project. So we go into HoleBASE, and a quick tour of the interface. So you can see it's a simple to use ribbon interface up here. Okay. On the left hand side we have what we call a Project Explorer. So this is all the different type of data that we could store inside HoleBASE. Okay. And at the moment we're looking at it at all of our boreholes we have in this particular project. If I wanted to, I could just say to it, well, only work on the south zone of my project, and it will alter, all my numbers will alter. So this is showing me I've got 13 boreholes in the south zone, etc. If I go back to all data again, you'll see that goes back up to 16 boreholes. So we could use that as a way of filtering down to look at particular boreholes. But on the right hand side is what we call our data grid. This is all of the information we have, in this case on my location details, is shown in this grid. So what I can do here, for instance, is I can go and open up a different grid. Let's come down here now. Let's go perhaps down to geology information, open up my field geology information. So here now I've got a grid containing all of my field geology, my USCS codes, my legend codes, extra codes we use for modeling later on called geology codes. I can just sort on those. I can filter on the data, so we're looking at all the different types of, in this case, geology codes or soil classification codes we have across the site. It's really designed to give you really quick access to this information. We can do the same thing on any type of data. So let me just go down here, quickly bring in my sample data. Do that again. Well, sample information, double click on that. In comes my grid of sample information. And again, on any particular borehole, I can sort, click, but I can right click on it as well and go generate me a quick log. And now, in a matter of a few seconds, let me just fit that so we're looking at the whole page. We have a boring log produced. If I don't want to use that style of boring log, I can go and pick some pre-designed ones. So here's another layout we have on it all. Now at the moment I'm showing this at a vertical scale of 1 to 75, but like I say, it will actually show me at a vertical scale of 1 to 100. And again, if we look at it, there's all my SPT blow counts and all the other information. We can, if this is designed to work on multiple screens, or you can design your layouts of your screens, so you can see it's quick, it's intuitive, easy to use to pull this information up and look at this information. With any type of data, let me just go into my environmental data. Here I've got some various information here. I've got PID levels on there, and what we've added here is a quick way of just color coding our data. So I've got here all my high levels, and what we call these things as trigger sets. We haven't got time to go and show you this in detail, but you can define all your trigger sets. So you can use trigger sets on anything you want as a way of banding data, and then very quickly I can just come in here and look at that, all the information, all the boreholes where we think we may need some remediation being done on that information. So it's a way of managing, pulling it all through together. Now the questions are, of course, is how do you get the data all in here to allow you to do this? Well, if we go up to our data, to our import section here, we can come through and we import data from plog, we can import data from CSV, we can even pull data in from GINT. Now I do have to add one or two caveats onto this. GINT project databases can be completely different from one to another, so when we are going to import from GINT, we have to do some pre-work to work out how the information in GINT maps through to the fields and tables we have in HoleBASE. We have to generate a sort of a mapping file, as we call it, to transfer from one to another, and once we've done that, we can use that to convert data from GINT into HoleBASE really at a click of a button by using this interface here. The other technique, yeah, sure, Stephen.
Question that's exactly directed at this comment. One question did come in on the chat about GINT, but also another question specific about porting data from EarthSoft's EQUIS. Do you know anything about that in terms of
yes,
porting the data?
Yeah, you basically EQUIS software, environmental data management sort of software. The way we would have to do that with those is EQUIS has a very powerful exporting capability. So what you do is EQUIS is export the data out from EQUIS as CSV data, and then we would be able to import the CSV information into HoleBASE. It's really a simple way of doing that. If we look at HoleBASE, any one of my tables, if I go to export, it will create me a CSV file with my header name and all my header tables. And all you need to do is create a CSV file that matches this criteria, and then you can import the data. And you will be able to do that with the information coming in from EQUIS as well.
Excellent, thank you.
Okay, thank you. So that was the wrong button I clicked on there. It should have been CSV export, there we go, and it allows us to export a file that way. So where was I? So yeah, we've seen how we can pull this information, we can generate quick logs on it, we can use it to analyze, sort our information. I haven't got time to do this now, but we can save queries and go back. So here, click on PIDs that are greater than 400, for instance. I've got one here now. So it instantly goes and highlights that data. If I want to see where it is on a map, zoom on map, and it brings up my mapping interface where I can see all of my borehole locations, where they are. We can actually overlay different types of information here, so I could go to my save search, and I've color-coded this already. So let me just turn off my locations, but we now got all of my PID levels across the site, all color-coded, showing me it. So it's showing you just quickly all the capability of managing the data, pulling it all in, then you can do this type of thing. We can also import DXS files, shape files, we can link through to web mapping services and pull different maps in the background, so a whole host of stuff like that. This is the tool to manage your data. If you can manage your data correctly, then you can use it for more and more different things. So what I'm going to do is move on here now quickly, and let's just come out there, back to my PowerPoint, and just show you, if you've got your data right, here's a little demo of using the data inside Excel. Okay, so this is the Excel extension that we've got for HoleBASE. So again, we're going to connect through to a database. I'll give my user details. All I need here is this extension on my machine with Excel. I don't actually need a HoleBASE as long as I can link to the central HoleBASE database. I'm connecting to a project now, and as I connect to the project, in my HoleBASE database, it's telling me all of the different sheets and style charts I've got created. So I don't have to worry about individual files. I'm just clicking on the one in HoleBASE. And now with that information here, I'm hitting on generate, and it's going to pull, as it generate, it pulls the information from HoleBASE into my local chart I've just created. And there we have, in this case, gradient envelopes for each of the geology across the site. So again, central data management, at a click of a button and you can start using this information. Very quickly moving on with this one, I'm just going to jump ahead a little bit. So here I'm just moving through now. We have another one that we're just playing with the idea. So imagine you've got data being collected from different lab results, different project phases, all coming in together. We've created this idea of a dashboard. So very quickly as an engineer, I can look at all the information I got across my site to give me a really good understanding of it. If I've got the data managed, it allows me to do this type of stuff really quickly, really easy. So here again, based on different types of data, so click the button and it pulls the data from HoleBASE and shows you it presented inside Excel. What we're going to look at now is really how do we go about doing this inside AutoCAD Civil 3D. So bringing this information through and showing it there. But let me just go and fire up AutoCAD. So, oops, wrong button. There we go. So in this case I'm using AutoCAD Civil 2017, but in reality what I'm going to show you now really works the same in 15, 16 and 17. So I'm just firing up standard AutoCAD, but we've got the HoleBASE extension installed into it. So AutoCAD Civil 3D, but you can see we have this extra ribbon called HoleBASE Si. If I click on the connect button now, what it's going to do is allow me to log in and connect to my database. So here I just type in my username and password, and as before, depending on what database they're connecting to, and what my username and password is, I get access to my project. So I'm just going to open up, in this case, my Quinley project here. Now this is not a particularly big project, there's only 28 holes in it, but if I was working on one, say with a few hundred or a few thousand, I may not want to bring the whole site in one go. I perhaps just want to pick on one zone of my site and tell it just to bring in those boreholes into the current drawing. Now, for demonstration purposes, I'm working with a blank drawing with no other information. Normally, you would want to do this in context, so you are seeing this information, perhaps with your site, with the ground model on there, all being pulled in together. But for this demo, I'm just doing it blank, just to quickly show you how things work. So there we have, we pulled in our boreholes onto the system. What I'm going to do now is just click on here and go to my what we call my location manager. Okay, and this gives me control over all the different elements I can see in my 3D boreholes. So if I could turn off the 3D boreholes themselves by just clicking on my model strip down here. I could turn off the plan symbols, or I could turn off individual ones by just clicking on the various checkboxes. If I want to pretend some boreholes don't exist, you know, I don't want to show my CPT one, I don't want this hole, I don't want that hole, I could just turn off complete holes. And what we're doing there is actually excluding them. It means to sort of pretend they don't exist. We don't want to model from that data. For now, I want to click and turn them all back on. At the moment, we're modeling on what we call my geology code. Now I've just done this using the UK configuration, so soil classification is not here, but if soil classification was here, it would just be listed on one of these. If I click on another box, I'm now doing my strata banded on my legend code. Again, go back in here, click on geology code, I'm now banding them by my geology code. I'm applying a 5 times vertical exaggeration. Again, I could just say, well, let's look at them at real size. Now I'll put them back at 5 size again. So you've got control on how they look and how they feel around there as well. The other thing we can do is I can also click on this icon here called strips. And let me just come out of here and go to my top view. We can also look at the boreholes and the log strips on plan. It's a great way of quickly looking at and understanding what geology you've got across the site and just looking at the geology codes and see what they are around the site. It's quick, easy to do that way as well to pull the information in. Now where things get quite fun, I'm not sure that's the correct word to use. I'm quite sad. Is when we come and start looking at this in 3D. So you notice I've got no surfaces here in my AutoCAD Civil drawing. But if I go up to the Strata Manager, this is now listing to me all of the different geology codes I've got in my drawing. Now, at the moment I'm linked into a different database in HoleBASE here, but when we go to our field geology and I clicked on my geology codes here, you can see it's basically showing me this list here. This is a different project, but primarily that's what it's showing me, and that's what I'm modeling this data here on. So as I click one of these, it actually goes ahead and generates me an AutoCAD Civil 3D surface joining all my dots together. So again, I click, in comes the next glacier tool, click again. Each time I do that, it's generating my surfaces for me. Okay, so again, if I come here now, just put this into shaded view, do a little rotation, it's generated that. Now, I do have to hold my hand up here. This data is actually pretty perfect to allow me to do this. In reality, it may not be this good. There'll be lenses in your data, pockets here, outcrops information there, whatever. So what you do have to do is learn how to model this data to make it look right, to look better, how best to draw it. Now, we have mentioned in July, the 19th and 20th, we're doing some hands-on training. I'm in the UK, in the US, doing some hands-on training, and a lot of that is explaining the techniques to model geology inside AutoCAD Civil, how you go about it, drawing feature lines, creating break lines, and the processing doing that. So if you are interested and you want to take this further, please look up at those training courses where we'll be covering that. I haven't got time to cover it in this webinar. But we've pulled this information in, and you can see we've started generating those surfaces. So we'll go back to the Strata Manager. You'll see by default, if I click on this little arrow here, we only show the top, but I could also set it to show me the base. And if I do that, you'll see that the base of my, in this case, my boulder clay is down here. Notice though, it's not using the base of any of my boreholes. If we go to the Strata Manager, you'll see that we've added here, include base of locations, because obviously the bottom of my borehole here, is only the last reading I took. It may, the geology strata may well go on past there, but if you do want to use it, we can just click on this button here, and it now starts using the base of my boreholes as a surface point as well. If we don't want to do it, I'll just click it off. But you can see we have this control over where we want to do it, how we want to show it. I can use my band by box like I did inside locations, so I could band it by soil classification. In fact, these are customizable as well in HoleBASE. So we have some customers, especially in the US, who all they care about is where does the rock start. So we've got one band that is soil and another band that is rock. And all they care about is where does the rock start. But we can customize it and you can use it that way if you want. So that's how we go about bringing boreholes in. That's how we go about looking at the actual generating 3D surfaces. Let's just quickly go back to the PowerPoint again. And what we're going to look at now is more detail at generating those dynamic geotechnical sections you saw me do earlier on. So let's just go back into the software again. Let's go back into AutoCAD here. Let's just take this back into 2D wireframe view. And I might as well do it with the drawing we've already got, so I'll just carry on with this. Let's put it into top view, go to view, and go to two viewports. Okay. And all I'm going to do here now is go back into HoleBASE and go to my create profile command, or create profile view command. We can give it a name. Let's call this one section AA. For those civil users out there, all I'm doing now is telling it which profile view style I want to use. So if you've got your own company standards, just use your own company standard profile view. And now it's asking me to create an alignment. I could pick my existing alignment, so I had a road alignment here. I could just pick that alignment line if I wanted to, but in this case I'm just going to do create. And let me just put a few points coming through, perhaps not from there, let's zoom in slightly closer from that. Undo. Sure, okay. Let's start again, shall we? It was going all so well. So let's go to create. I'll call this one section AA. I'll tell it to use my profile view alignment, create an alignment, and let's just do one, say, coming from here, down here, zoom in a little bit closer, around here, coming down here, that will do. I'm not going to hatch the whole thing, so by this you can see I can tell it which strata profiles I want to use, and do I want to automatically hatch them. I think just for now we'll just turn those off, hit next. So now it's asking me, well, what type of style do I want to show my geology strips in? Well, I'm going to use my standard geology code just for now. But here it's asking, well, we're going to use a buffer. So it's going to look 20 feet either side of my alignment to find boreholes. Now I could make that number larger, so it will find more, or smaller. But you'll see that I've also got toggle beside it dynamic, which means if I move my alignment, it will look for new boreholes later on. So again, with that done, we hit finish and then place where we want my alignment to go. So there we go. So zoom out here again, so you can see now, if I drag my alignment to another location, how it updates the profile for us. And notice also, depending on the hole type, so here we've got some rock recovery information, core recovery being shown, so it's showing me the appropriate borehole style for that. Over here we've got some water strikes being shown, so it's showing me the appropriate borehole style for that. If I was to move my alignment so it goes through where we've got a CPT hole, you can see it's now showing me CP hole strip information coming through. You can just see how quick, how easy it is to do that. You know, if I wanted to, so that's one of the benefits. But obviously in the real world, what's happened as a CAD technician, you've been asked to do this, you're working away, and your HoleBASE guys have gone back and they've just added a whole new set of boreholes onto the project or added more information to it. Well, the beauty of using central data management and using a tool like this is that I can come in here now and literally go. In fact, you would normally use the update button to pull the data in, but to save time, I don't know if you remember, but I told it only to work on the south zone. So imagine I had imported the north zone into HoleBASE. You'll see the same effect now by me just going north zone here and hitting save. What will happen now, you see the civil 3D surfaces have been updated, the profiles have been updated, and all I have to do now is just, let's just move that over here somewhere. And now all my section has all been updated with the latest information as well. So as you work on this, it becomes quicker and quicker and easier to manage your data and manage your updates, bringing it in and looking at it. And you remember 50% of the people on this course said it took them over an hour to generate a cross-section, what we're just doing here, which we're now doing in seconds because we're managing the data correct on it. We talked also, so it's a really powerful tool. And obviously we can do sections any way we want to. So let me just do another one here now. Let's go to the profile view, create another alignment. Let's do this one, let's say going from across my site like so. Go to the next page. Perhaps I want to do this using my legend code strips instead. Hit finish and we'll put that up here somewhere. So in it comes showing me this information on here. Okay, so you can see we've got legend codes. In fact, you zoom in here, we've got some quite interesting hatching where we multi-layering hatching upon the system. And these, by the way, is just standard profile views. So I can just go, click on my profile view manager, perhaps come down here, alter the depth of it. Perhaps I want to start it from -10 feet as opposed to what it is at the moment. And you can see it readjusts it. And I can go back into HoleBASE. I do have to do a little bit of jiggery-pokery here and just tell it to rebuild my profiles. And now you can see all my boreholes laid correctly on top of my profile view there. So hopefully you can see the speed and ease you can do that. The last thing I really want to go and show you, I'll just quickly nip back into the presentation just to remind myself, and that is now looking at different downhole data ways we can do it. Well, we've already seen we can do it in our log strips. We've got water strike information, we've got CPT data. In fact, they can be customized and you can show any type of data in those log strips that you're looking at. But we can also do, in fact, what I'm going to do here is just bear with me. I'm just going to close this drawing down. And I'm just going to fire up AutoCAD again. The reason I'm doing that is I just want to connect through to a different database this time. Okay, coming up to the end of my allotted time slot, so I have to make this quite quick. So what we've done is I've just gone back into AutoCAD, and what I'm going to do is connect again. The reason I've gone back in is I just want to connect this time to a different database. So I'm going to connect to my ASTM database again, pull that information in. So this time, because in HoleBASE, you remember we've got so much different type of data we can store, well, I want to view and visualize that information as well. So I'm just pulling these few boreholes quickly into, it's only a small site, but it will show you how it works. So we've just quickly pulled in these boreholes here. And you remember inside HoleBASE, already open, we have a whole host of different types of data being stored. So here I've got my sample data, I've got my environmental data, all being stored, being used here. How do I show that information and visualize it? Well, we can do that through this XYZ, or I suppose I should call it XYZ point group information here. So you click on that, can you see we have that same data structure being looked at down here? In fact, I can also tell it to use my north and south groups and stuff like that being represented down here. So I can come here, for instance, and go to my whole construction where we have my water level information. So we hit next on that, and we have all of my water strike information across the site. So what I'll say to it is actually what I want to do is map out at the time of drilling where my water levels were. So let's hit close on that, hit next now, and this is going to be my water levels at drill time. And I want to plot them at the appropriate height. You can see here, this is the information I'm going to get coming in from this. So on to the next page here, and it's asking me how do I want to label it. Well, I'm just going to say to this one, add to it the reading event, and I'm also going to add to it my depth as well. And you can give me here a little what I'm going to get. You can see, by the way, on my apologies, made up data here, not real data, but I will show you what's happening. So now across the site you can see that we've got my little marker showing me what all the different water levels were across the site. In fact, in 3D you'll see a problem because my marker's a little bit too small. So all I'm going to do here is just right click on here, and there we have water levels at time of drilling. Let me just go to the properties on that and just go and edit the style that I've used. So I've just used a point style. These are standard AutoCAD Civil points. So I just edit that very quickly, and I say to it, well, actually use absolute size. So let's say I want my markers 12 feet across. Hit apply, hit OK to that. and now you can see where my water-like strike levels are. And I could go through that same process again. I just do this very quickly. So we come into it again here now and go, okay, I've got at the time of drilling, but what I want to see now is what they're like 24 hours afterwards. Okay, so we'll go through the same process again. Water levels at 24 hours. We'll do it at elevation again, hit next, go through the same. I won't bother labeling it this time, but now you can see we have a second set of symbols around. And again, all I have to do here now is either edit the style, or in this case, I've just added some other markers on here. So let's just apply that one and add that one. So now we have a little green marker where it was at 24 hours later and where it was found. Again, remember this is made up data, so if it looks wrong, don't worry about it. It's just the data that we put into the database being on here, being shown. So that's one way we've got of visualizing the data. And you think you could use that really for anything you want. Where are all my sample locations? You know, where have we found test results above a certain value or below a certain value? You can really use it for anything you want in showing and putting into your 3D model. The other technique you've got is by using the XYZ surface command. So again, it takes you back into the same information you saw beforehand. But perhaps I want to generate, in this case, a heat map of arsenic or of contamination levels, or I want to show sort of the bearing ratios across the whole of the site. And I've got that information in, I want to show that across my site. So we can use this to map and generate sort of 3D surfaces based on any data we've got in HoleBASE. So I'm going to come in here now and tell it to use my environmental data and tell it I want to filter and only use my PID readings. And to make sure everything's correct, I better come over here and say to it that I should only work on PID where the units are parts per million. So let's filter on that as well, and we'll bring that information through. So this is going to be a PID heat map I'm going to create. Okay. I'm not going to do it at elevation, i.e. where the readings were taken from. I'm actually going to use the readings themselves, the concentration value, as the Z value. And because I want to know where the worst areas were, I'm going to use the maximum found down the hole. So you can see a whole set of data being shown here. So I hit finish on that now, we get a crazy looking surface. So let me just show you this, how it should be looked at in 2D, and we have our Civil 3D surface there. But what I'm going to do now is, just to finish this off, is go to my heat map and go to Surface Properties. And I'm going to tell it, I'm going to create a new style for it to use. Okay, and all I care about is this Analyst tab. I'm going to tell it to use elevations. I'm going to tell it, let's use range, let's say some form of rainbow color set we're going to use. We're going to use equal levels, and we're going to use 3 ranges, and we're going to tell it to use 3D. So this is really telling it how we want our surface to do. You would normally save this as a predefined style, then just use it time and time again. So with that done, all I have to do now, that's all set the way I want it to show, I go to display and say to it, when you look at this in plan, don't show me the border, but just show me the elevation information. I'm going to go to model. I'm going to do the same thing in model space as well. There we go. And hit apply on that, and OK again. So now what we've got is a color-coded model representing the information that we got, the high levels, the low levels. If I want to fine-tune this, I can go back into my properties again, go to Analyze here, and I can actually just come down here and actually say to it, well, actually, let's make the banding a little bit more sensible. Anything up to 350 perhaps should be is okay. Perhaps anything between 350 values and say 500 concentrations perhaps needs some form of investigation, so we'll do that as sort of amber. Anything over 550. I'm not a geoenvironmental engineer, I hasten to add, so Please ignore the values I'm putting in here. That's not 550, that should be at 500. It's more to show you the concepts of what we're doing here. Let's make that red. There we go. Hit apply to that. So now we've got a heat map being generated with the data from HoleBASE. If the data from HoleBASE updates, we can then use update here to see that data. If we want to make this slightly more aesthetically pleasing, I could come across here to smooth surface and say to it, well, I'll tell you what, let's smooth it based on my polygon surface area. Let's do it, I don't know, 5 feet by 5 feet. That will do. So we now have a nice smooth image showing us where we've got high levels of contaminants and not across the site. So again, just another technique we've got here at visualizing that centrally managed data inside HoleBASE. So we're just about at the end of this now, so thank you very much for your time. I have got various examples here generated by my clients. We're running out of time, so we can't go through it, but this is a project in London for a new tunnel under the River Thames, road tunnel. And here our clients Atkins, together with the Transport for London, have generated a geotechnical 3D model, put in a lot of information in there, and they've told us they have found so many benefits from this. As they use this, they're finding new and new techniques, and it's been a real big bonus to them and benefit in actually taking the trouble to model all the geotechnics. And then the wider construction team are finding loads and loads of benefits from it. One, for instance, was just doing acoustics. Apparently you have to do noise testing of how noisy the tunnel is going to be in the middle of the river. Apparently the fish don't like noisy surroundings or something, so they told me. And they said they could just take the sections they off to do that, to do the analytical work so easy once they had the whole ground model and everything created to do that. This is another one. It's a relatively simple, crude model done by clients in Australia. So they haven't spent very long in actually modeling the geology, but they have used it to show, and as a thinking tool, really to show different tunnel locations and the type of geology they would run through. So again, it's just using this information and pulling it through from HoleBASE into AutoCAD Civil, and then they generated the sort of simple animation showing the type of geology stuff to do it. It's better to understand, to get a better understanding of what's going on. So thank you very much for the time. I'm just going to hand back to Stephen now, but I hope you found that of interest. And of course, if you want to know more about it, please do attend the training courses that we have arranged for you. So thank you very much for your time.
Great. Hey, Gary, just one a question that kind of came up a couple of times regarding sharing of information. A couple of people who have been using the geotechnical module, they're interested in what's the best way to share that information between their workstations, and I think it dovetails because there's a couple of questions regarding the differences between geotechnical, the module, and HoleBASE SI. So maybe you can touch on just a quick summary of the differences between the two. Yep.
Yeah, good question. So I sort of didn't really mention the geotechnical module at all. So the geotechnical module is a piece of software that Autodesk supply to all AutoCAD Civil 3D subscription holders to model geology. If you were to look at it, you will see there's quite a close resemblance between it. Let me just go and go back into AutoCAD again. Between it, I happen to have it here. Now, if you notice, there's quite a big resemblance between the two. In fact, they all use the same icons. That's because Keynetix, we developed the geotechnical module for Autodesk and licensed it to them. So it's actually a cut-down version of HoleBASE Si extension for AutoCAD Civil 3D is what we got there. So, but it's designed to work on a local machine with a mini little local database, so only one person can drive it working on their own machine. If you want to use the geotechnical module and share common data and have 2 or 3 people on different machines trying to work on it, then you've got 2 choices. You can use the geotechnical but linked into the HoleBASE Si database to access the data coming from there. But if you then want to take it further than that and for some of the people on this call, by the sound of it, you may be quite happy using the geotechnical module. But if you want to use things like water strike levels, so in fact, if you see here, we don't have any of this functionality I just showed you with point X group and surfaces. The other thing is that it won't show you things like water strikes, rock recovery, CPT data. In fact, the geotechnical module really only works with, and we'll go back into HoleBASE again very quickly. You see we have all these different tables of information. Well, the geotechnical module will work with my location detail one, my field geology descriptions, and there's one other regarding hole construction, that is orientation, inclination. So if you've got inclined boreholes, it will show that. But all this other data, my sample locations, my in situ test results, environmental data, all that other information, the geotechnical module can't work with that. So it's a great starting point, but it will only work really with geology and soil. Anything else, the geology model can't take it any further. Likewise, if you want to share data with a wider team and work with a wider team, the geotechnical module won't be able to do that. So hopefully that answers that question for you, Stephen.
It does perfectly. Thank you, Gary.
Okay, excellent.